Hello, welcome to another video. Today I'm going to explain about a basic component of electronic circuit. Diode is a basic component which flows electricity in one direction and blocks from other. This is a very simple but useful component in the field of electronics. Let's directly jump to the matter. What happens inside this material? So let's start. Diode is a two-terminal component. It emphasizes that it is a mixture of two types of materials. These two types of materials are called p-type and n-type. P-type material has more holes than electron. Now, what is hole? Hole means absence of electrons or has an appetite for electrons. P-type material always tries to fill their last orbital with electron, which means this type of material is enriched in positive charge. N-type is just the opposite of p-type. This type of material donates their extra electrons to other compound. They have electrons in their orbital more than enough. So, they're always ready to donate this electrons. And, of course, they're negatively charged. And alternately, p-types are called acceptor and n-types are called donor. P-type example, boron, aluminum, etc. N-type example, phosphorus, arsenic, etc. This p-type and n-type materials are connected together. This is a real image of a diode. When these two materials are connected together, what happens to this compound materials inside? Let's see, as p-type materials have plenty of holes, so it always get excited when there is any trace of electrons. So, for the presence of n-type materials, it gets excited and attracts the electrons of n-type material. As n-type material contains donor atoms, so it easily will provide electrons. So, a series of atoms will move towards p-type material and creates a layer at the front of p-n-type intersection point. Same things happen for holes. This will create a layer at the intersection of p-n. So, overall, there will be neutral layer of same number of electrons and holes. So this layer will act like insulator. So overall we found three parts: p-terminal, n-terminal and p-n junction. So, this diode is called p-n junction diode. Now, if we connect a battery to this terminal, as we know current flows from positive to negative, this connection of battery to the diode is called bias state. And diode without any battery connection is called unbiased state. Bias state can be happened in two ways. First case, connect positive point of battery to the positive terminal of this p-n junction diode and connect negative point to negative terminal. Now look what will happen here. Positive point of battery provides positive charge to the p-terminal of diode. So, there will be a new series of positive charge or holes. This extra addition of holes attracts the negative charge. So a layer of negative charge will break down and neutralize this positive charge. The junction became thinner and the conductance between two terminals will increase. So, the remaining positive charge starts to flow through the junction and ends up to the terminal of n-type. This phenomena creates an electricity flow from the p-terminal to n-terminal. So this type p-n junction diode acts like conductor. This bias condition is called forward bias condition. Now, case 2, just flip the battery. The negative point of battery will connect to p-terminal of diode. And positive point will connect to n-terminal. This time again give a closer look. The positive points of battery provides positive charge to the n-terminal. Now the electrons of n-type materials will attract to this positive points and move to neutralize this. So there will be a series of electrons which move towards it. At p-type, same things happen. The holes will move towards negative points of battery. So, this movement of hole and electrons will increase the depletion region. So, another layer of same number of electrons and holes are added to this junction. So, the junction width will increase significantly. An insulator layer increases and current stops to flow. This neutral layer at the junction is also called depletion region. This bias condition is called reverse bias condition. So, in summary, The diode has two states: number 1 biased, number 2 unbiased. Biased condition has two types: forward biased and reverse biased. Unbiased condition: in this state, no voltage will create and no current will flow. Forward biased condition: electricity flow through P terminal to N terminal. This is called forward bias current, and the voltage for this we'll call forward bias voltage. Reverse bias condition: in this state, there should no current because of the increment of depletion layer, but a very little amount of leakage current will flow through. This little current is called reverse bias current, and the voltage create for this we'll call reverse bias voltage. We'll talk about this leakage voltage another day. Why does this current create and how? Last of all, there are many real-life applications of this diode. One of them is rectifier. This rectifier is the main circuit of a mobile charger. Interesting, isn't it? We'll talk about another day about rectifier circuit and mobile charger circuit. Now, I think you understand the importance of this diode. That's all for today. Goodbye.